brave ones that rushed back from lunch. So, once in 2001, I gave a presentation in Denmark, and I'd done some research there on risk-based approaches for demonstration of freedom. And I'd been doing some research for about 3 months, doing quite exciting modelling and very complicated statistics and mathematics, and there was a final presentation, so I stood up and gave the presentation. But unfortunately, my wife was sitting at the back, and after everybody, came up and said, well, this is really, really complex but very interesting, she came up and said, Angus, that's just common sense. And since then I thought, well, maybe we should actually go for more of that, because common sense is all too uncommon. So that's what I'm going to try and do here, try and head in that direction of presenting a little bit of common sense. The context is the Northern African EuFMD outbreaks from 2014-2015 that have been mentioned and discussed and analysed in several presentations previously. So we've been working, I and my co-authors, on aspects to do with surveillance that have come out of those outbreaks. And there are many different issues that have arisen to do with surveillance, and we're focusing simply on one of those, which is surveillance to detect early detection of disease. There's I have to do that. There's the outbreaks, coloured by species or primary species involved. So it was a very, very impressive series of outbreaks and great data set to analyse. Really a huge amount of fun for everybody other than the veterinary services that were doing something about it. What I'm going to be talking about is a little bit on principles of EuFMD surveillance, then moving on to quality standards. Early detection, risk, a bit of economic modelling. I'm not an economist, so I'm going to stuff it up, but you can tell me what I've done wrong. And then finally, trying to come out with something that is reasonably practical at the end of it. So, some of you, I'm sure, have heard me say this before, but this is the way I like to think about surveillance, because surveillance is such a broad area. We need to narrow it down to understand what we're doing a little bit better. So I break it up into surveillance for disease when it is present, and that's things like measuring disease, trying to estimate prevalence, trying to estimate seroprevalence for vaccination coverage and so on. And also, when the disease is present, finding cases, doing something about it, case detection surveillance. We also do surveillance when the disease is absent, and we do that to demonstrate that it's absent, so we know when to end the control program, or we can open up trade opportunities. And the other one, when it's absent, is we want to do early detection surveillance. And all of these different types of surveillance have different purposes, and as I hope you'll see, we need different approaches to make them work. But for all of them, and for early detection surveillance, we need to ask some questions. How much should we do? How much should we spend on it? And normally, when we talk about surveillance, we go to the international guidelines. There's a whole lot of bright people around who've done some really excellent work with the FAOs and OIEs of the world and various other ones, writing great guides to help us manage disease. So I thought I'd go to the international guidelines, and I went to the OIE code, Terrestrial Animal Code. And it tells us some really interesting things. It tells us that every country has to have an early detection or an early warning system. And then I continue hunting, and it says that disease reporting and non-random surveillance can be useful for this. And then it sort of dries up. There's not very much specific about how to do it. So go across and have a look at FAO, and there's a bold, this is the Manual on Livestock Disease Surveillance, there's a bold statement right at the top there which says surveillance has as its main purpose early detection of disease, which is fantastic. I thought I was onto something. Continue looking through, really all we get is that passive farmer reporting can help with early detection, but nothing specific about how to actually do it. I don't know if your experience has been the same, but my experience is that we all agree that this type of surveillance, early detection of incursions, is really, really important. It's the key to minimising the impact of disease outbreaks. But there's very, very little guidance on how to do it, and there's very little guidance on how much to invest. Now, we've heard a few presentations on tangentially related issues, but I want to try and attack this sort of head on. Okay, in order to determine how much we need to spend or how much surveillance we need to do, there's a step we have to take. This is a really irritating thing that epidemiologists do, but we need to start way back at the beginning. So you go to an epidemiologist and you say, what sample size should I use? And how much is it going to cost? And then the old epidemiologist comes back and says, well, how good do you want it to be? And how much money have you got? Right, so let's use some examples so we know what we're talking about. Quality standards, what are these? So if you're using quality standards to measure the level of disease, this is seroprevalence, incidence like I was saying before, the standards that we use are precision. So how precise do you want your answer to be? That's half the size of the confidence interval. And bias. Do you want your results to actually be believable, or by eliminating bias, by using representative sampling? Or are you perfectly happy to have some terrible bias in there so that the results are fundamentally wrong and the decisions you make will be wrong on the basis of that? When we talk about case-finding surveillance, again, an under-discussed branch of surveillance, which we absolutely need to do in disease eradication programs, we have quality standards, and so one standard would be what proportion of the real cases out there do we need to find? And it's really a type of surveillance sensitivity. How good are we at finding these cases? And I suppose I would ask, are we able to eradicate disease successfully if our surveillance sensitivity, our capacity to find cases is less than 100%? Or do we need to actually find every single case and respond to it? Demonstration of freedom, another branch of surveillance that I've been talking about. The quality standards we use here are a little bit more complicated, but design prevalence. When we say it's free, what do we really mean? What is the minimum prevalence that we would expect there to be, we want to be able to detect? Or what's the... no, I'm not going to go into that. Surveillance sensitivity is one measure that comes out, how likely we are to find the disease if disease is present at this design prevalence. And another measure that we can use if we go onto a Bayesian approach and start combining historical data and multiple sources is the confidence in freedom, which is much more intuitively understandable. Okay, so those are examples of our quality standards. What are our quality standards for the early detection of incursions of disease? Nobody's going to answer. Okay, it's the same sort of thing as I was just saying, detection sensitivity. What do we want the probability to be that if disease comes in, we are going to find it? So we can set as our standard a target probability of detecting, a sensitivity for detecting the disease. So that's our detection part of early detection, but there's another part, which is the detection delay. And we're saying early detection. So that implies that we want to find it quickly. And we need to set some sort of standard. How quickly do we need to find it? And that's a huge question. There's many ways of answering that. The most practical response I've heard to that question, I think in the past, has been, we need to find it before the media finds out. But I'd probably go with something a little bit more scientific and say we need to find it in the first infected epidemiological unit before it starts spreading to other ones. So I would contest that if we want to have an effective early detection system, our target should be that we detect 100% of disease incursions. If we say, no, it's all right to have one or two incursions of foot and mouth disease into our country, don't worry about it, but we just want to get the rest, I don't think we're really doing our job. So the target is probably 100%, and as I said, what's the implications of that? Sorry. If we want to detect 100% of disease outbreaks, what proportion of the population do we need to have under surveillance? 100%. How do we do surveillance in 100% of the population? We can't do a survey, we can't take a nice little sample. Life starts to get complicated. If we want early detection, how often do we need to test all of the population or have them under surveillance? Basically, all the time. And how can we do this? Well, the answer there is actually pretty simple. There's only one surveillance activity that we have available to us that is able to achieve this, that has a whole population, or a huge proportion of it, under constant surveillance, and that's using the farmers that actually are in touch with the animals, care about them. This all falls down. We talk about wildlife surveillance, or we talk about extensive farming systems, but that's the best we can do. How effective is it? Yeah, not so good. There's all sorts of problems with it. It's variable. So, just quick conclusions, and this is not the end of the presentation. It's the only practical tool, but if we want to improve it, if we want to address this problem, that in many cases our farmer reporting systems are weak, we have to do something about it. We can invest. And the question is, how much do we invest and where? We can invest, I'm going to have to keep going here, I'm not going to read through this. We can invest in various ways to improve the sensitivity of the farmers, or to supplement the surveillance by doing other surveillance to fill the gaps. And this is where we come to the risk-based component. Now, we do risk-based surveillance, risk-based activities to try to make things more efficient. We want to get the same result at lower cost, or we want to get better results at the same cost. And we identify subpopulations at higher risk, and then we focus our surveillance efforts on those subpopulations. And we can do it for freedom, demonstrating freedom from disease. That's really where a lot of the risk-based methodologies came from. Excellent stuff. Case finding, we can do it. We can focus on those areas where we've got a higher chance. It's still a bit dodgy there. Prevalence estimation, of course, do not do it. Not risk-based for prevalence estimation, because you're intentionally introducing biases. It's a bad thing to do. Can we use risk-based surveillance for early detection? Well, problem is, all of these other things are based on probability theory. When we're talking about freedom from disease or estimating prevalence, we are using probability theory to justify what we're doing. And probability theory is based on repeated events, and if we toss a coin once, I don't know whether it's come out negative heads or tails, but if we toss it 1,000 times, I can predict the future. I know what is going to happen. I have a certain amount of confidence, and I can quantify that confidence that a certain result will come out, which is great when we have repeated events. The problem is that disease incursions are not repeated events, we hope. What we want is them to be a single event. It's a one-off thing that we need to detect. And so we cannot predict probabilistically where it's going to happen. We can say it's more likely to come in this area or that area, but we can't say where it is going to happen. We can say if there's 1,000 disease incursions, then more than half of them are going to be in this area because it's high risk. But we don't know where the next one is going to be. So pure risk-based approaches start to fall apart when we do that. Right, so the general rule is that if we want to base our early detection solely on risk-based approaches, it won't work. But we can use these risk-based approaches to focus. Okay, if we're going to invest, where? And we need to consider variability. So, there is variability in farmer reporting. We've got some areas where there's good veterinary services, high awareness, intensive farming, good reporting, and we've got other areas that are bad. So we probably want to try to achieve uniformity by investing in those weaker areas. That would be logical. That's a way to use risk. But we've got other things happening. We've got variability in the risk of introduction of disease. It could come into this area or that area. So maybe we want to focus our surveillance towards areas of high risk to have a better chance of identifying it. And then there's this other side of the coin. There's the consequences. Outbreaks in certain industries, certain production systems will cause higher consequences. So if it gets into a market, it's going to spread quickly, as opposed to getting into a remote farm or a farm that only sends animals for slaughter. So we've got all of these different variabilities. How do we bring this together to decide where we're going to focus? And we do this by considering all of them. We break down our risk into the various risk components, and combine them in a lovely formula. And I told you this was going to be easy and intuitive. Common sense. So there it is. We've got the expected cost as the outcome there of outbreaks, and it's based on the probability of introducing the disease. 1 minus the sensitivity, so the risk that we fail to detect it, and then the cost of the consequences. And if you sit down and work out these numbers, you're basically doing risk analysis, and you're coming up with the expected cost of outbreaks, and it'll tell you an absolute value, which is the absolute amount of money that it is justified to spend to prevent these events. And, oops. Here's the economics bit. You can look at, oops, that's not working. Try that. Here we go. So this is our investment. As our investment goes up, our probability of the cost of the disease goes down. And if we look, but the investment costs, and so does the disease, and so the sweet point is where the cost of the investment and combined with the cost of disease is at a minimum, and so that's exactly how much money we want to spend to prevent disease. Economists love these because there's no numbers on the axes. There's never numbers because you can't do it. It's a lovely theoretical approach, but it's just too hard. Yes, we can do modelling, we can do stuff, but an alternative approach is to, rather than worrying about the global amount that this is going to cost and how much it's legitimate to invest, instead we can look at the partitioned cost in different subpopulations, and that gives us a bit more of a useful idea. And again, it's easy. All we need to do is fire up Excel and start doing some modelling and put in some numbers and run some stochastic simulations, and we come up with the answer. Yeah. But it's still really, really difficult. So what I was trying to do with this work was trying to come out with something that was going to be more practical, and that is to look not at the absolute costs, but the relative costs, the relative risk, because these are much more intuitive and simpler numbers to estimate or even sometimes to measure. So, here's an example. We've got the, oops, I don't press that button. There we go. We've got the relative risk of introducing into an area in a high movement area compared to a low movement area. We might say that's 3. We've got the risk of failure to detect it in a remote area compared to an area with good veterinary services. We could say that's 4 times different. And maybe the relative consequences. If it goes into a breeder farm which is selling animals to lots of other farms, it's 5 times more likely to have, the consequences are 5 times greater than if it went into a farm that only sends to slaughter. So we can come up with these numbers relatively simply, and all you need to do is multiply them together. You don't need Excel, you don't need stochastic modelling, you don't need fancy stuff. Just multiply the numbers together, and you come up with something like that. Partition the population into the various risk groups, and here is the proportion of your available budget that you should be spending to address the risk in different areas. So what we're saying is, if you have an area where it's likely to get in, you're likely to miss it, and the consequences are very high, that's probably where you should be spending a large proportion of your resources. And you can see the breakdown of the rest. Now, once you decide where to spend it, you've got a range of interventions, things you can do. And, but it's not just surveillance. So we can actually use these resources to prevent the introduction of disease. We can use it to make sure we detect it better, and we can use it to reduce the consequences, maybe having better biosecurity to stop the exit of disease out of markets and farms and so on. Just one last little note that all of this investment, it's only worth it if it actually has an impact on the disease. We can justify a certain amount of money or a breakdown of the investment, but if that goes to buy a new car for the Director of Veterinary Services, it's still not really going to have much of an impact. So that's the other part of the equation. Some quick conclusions. This is all about risk analysis. We're using risk analysis approaches to try to identify how we can use simple methods to better prioritise our expenditure for different risks in different areas. We need to look at early detection surveillance as a component of a whole risk management system. And so stopping disease getting in, finding it when it does get in, and making sure that the consequences are managed so that it doesn't spread are all part of the system. And so for somebody who works pretty much solely in disease surveillance, here I am advocating, don't just think about disease surveillance, think about the other parts of the equation as well. The pharma reporting system is the foundation of all of this. It is critical, and there's a lot we can do to improve it. And there is some very good work happening at the moment looking at ways to do that, which I haven't got time to talk about. I suppose a major point that I'm trying to make here is that a lot of the work we see in this area is very complex, very, very interesting, but we can actually get some quite useful results with some very, very simple estimates. And no need for very complex analysis.
You have 1 minute.
And the last 3 lines, that we can address risks by addressing the 3 different components that I've outlined. Thank you very much.
Thank you very much, Angus. I think it was a very challenging presentation. I'm sure there will be questions from the audience. Please. Yes.
I would like just to add 2 small elements to these excellent presentations. One is for early detection of disease, of FMD. We need case definition, because the case definition in naive population of animals is one, and it's totally different when it is a vaccinated populations. In one, we could decide that the case will be clinical symptoms. In the other, that they manifest, for instance, NSP positive or virus presence or whatever. This is first. And when we are discussing risk analysis, we should, when we assess the risk, we should assess also the vulnerability of the system that we have. And we should assess the risk according to the weak points of our system. Because in every country, they have different level, different standards of preparedness, and the risk should be measured according to their own standards. Thank you.
2 very good points. I agree entirely. Yes.
Is there a, yes, there is a question.
Hello, Angus.
Oh dear.
Oh dear. Well, thank you for an excellent presentation. I have a problem though with epidemiologists' use of passive and active surveillance. I think it should have been some terms that epidemiologists only use when they're in a room with nobody else there and the doors are locked so that nobody else can hear it, right? Because active is a positive word, passive is a negative word. And in my view, in veterinary administration, farmers reporting is the most valuable type of surveillance you can have, right? And that's also my impression from African swine fever in the Baltic countries, right? It's very difficult. African swine fever, a pig gets infected, it shows clinical symptoms that are unspecific, it gets a high fever, within very short times it drops dead, right? Despite this, the subsistence farmers, backyard farmers, they notify to the veterinary authority before these pigs die. They have noticed the clinical signs and reported it. So I think that in general, we should speak more positively about farmers reporting, because I think you're right. There's a lot you can do, and it's a problem afterwards for us calculating the numbers and so on. Yes, that's true. But in some way, it would be nice to show how valuable it really is.
Can everybody just tell me, did I actually say the word passive or active during that presentation? No, because I agree with you entirely. And I think Sten, you heard it when I said farmer reporting. You heard passive, because we all do. But I agree entirely, and in fact, a ridiculously large proportion of my life at the moment is dedicated to trying to improve the farmer reporting system, because I see it as the foundation. But I did intentionally try to avoid using those words, passive and active, because I agree with you entirely. Thank you, yes.
There is any other question from the audience? If not, thank you very much, Angus.
Then I would like now to invite José González